Our final task in this module having to do with RRAS, but not the final task of the objective itself, has to do with configuring routing. And as I said, routing is one half of the routing and remote access services that make up RRAS here in Windows Server 2012 R2, but you find the actual routing bits not being used all that often in a production sense. Now, the reason for this is because there are a lot of other tools that are perhaps better at doing this kind of routing than a Windows Server, and probably for a lot less cost. So you don't often see a Windows Server used as a router in all too many organizations. That said, however, there are functionalities built here into RRAS, obviously since routing is in the name, to support routing between different subnets in your network environment. You can take a look at here for any of the interfaces you have. Let's take a look at the internal server net here for the IP routing table that exists for this particular connection. So as you can see here, any traffic that attempts to go to any of these destination networks across any of these network masks will be directed to those networks using these gateways and these interfaces or these network cards. Now it's possible here with routing to actually enable multiple different routes in a network if you have that complex of a network where there may be multiple paths from one place to another. And when you configure those routings, you have a way of determining the cost or the weight, or as you can see here, the metric for that route. This metric defines which of the routes that the routing protocol should use, in what order and by what priority, with the route having the lowest metric being the one that's chosen over those with higher metrics. Over here under the static routes view is where we can define or override the existing routes that are automatically configured here by the server itself. If you know you should have a specific route that you want traffic to go when it passes through this RRAS server, you can define what the interface should be. So is this the server net or outside? What the destination should be, what that destination network or host would be, the network mask, and then the gateway also for that machine. When you make that configuration, the metric here is what determines which route the RRAS server will send the traffic down. Because again, the lower number metric is the one that is chosen until that route is no longer available. Again, this configuration of routes and static routes here is something I'm not spending too much time here on, just simply because you don't see it all that often in a production sense, but I would be aware of what these static routes are and how you would configure them, how if you needed to get to a specific network, you would populate this static route, and then also the awareness of the metric configuration so that you can get that traffic to its destination via the most appropriate path. Having multiple paths, multiple static paths, then further ensures that should one path go down, that you have an alternative path to get that traffic to its correct location without incurring downtime. I would also be aware that in addition to calculating static routes here, that RRAS actually supports a routing protocol, the RIP-v2 protocol, that you can access here by right-clicking under General and choosing New Routing Protocol. RIP-v2 is a mechanism that can automatically figure out what the best possible routes are between routers in an environment, and then use those routes as a mechanism to determine how to transfer packets from one location to another. When you configure RIP, you need to identify what the interfaces would be for RIP. So, for example, if you want to turn on RIP for a specific network like your server net, you would need to add the interface here. RIP-enabled routers communicate with each other to try to figure out what the topology is for a network. And so it's here where you can identify which protocol is being used for outbound and inbound communication between those routers. If you want to turn on authentication, if you want to secure those connections, if you want to identify what your neighbors are and how to actually find those neighbors, and then any advanced configurations that are over here. The use of RIP-v2 becomes more important as the number of Windows-based routers you have in an environment goes up, because just simply configuring all those static routes gets sort of tiresome over time. And it's RIP that can automatically identify when a route is no longer available and then redirect traffic in whatever appropriate way to ensure that that traffic continues to get to its appropriate location, all via an automated approach that reduces the need for the configuration of static routes.